working on an iOS game, and I have 8 textures currently visible. If I add a 9th texture, I'm doubling the...
No. That is, first off, that 8 texture limit is hardware dependent, and I was referring to desktop hardware. I don't know what the limit on iOS is. I think it's lower. I think it's either 2 or 4, depending on the version of iOS.
It's 2. And
it is 2?
It's 2, and but it's per,
yes,
per material. Yeah.
For what?
Per material or object.
Two per
But
material.
2, yeah.
So you should be working in sets of 2. So if I add 3, I might as well add a 4th, and it wouldn't be that much of a difference. But it would double if I add a 4th.
I think that I'm working with GL version, the GL version 1. I think that 2 probably, ES2 probably has more than 2. So I'm not sure.
A lot of this is limited not by the API, but by the hardware. So particularly for iOS, you need to decide what iOS device you're calling your minimum. Are you doing the iPad? Which iPad? Are you doing the phone? How far back are you going to go? And unfortunately, the only way to know this for sure is to go read the hardware specs for each of these.
Thank you.
So it's more of a, I think I kind of know the answer, but so in my game, I'm working specifically. I asked Unity to work for GL version 1, which obviously turns off a lot of features. As soon as I turn on version GL ES2, for all my already existing shaders, my CPU, my frames per second drops significantly. And I'm still kind of in the dark and trying to find the smoking gun for this thing.
Do you know what hardware you're running on?
I'm talking about like iPad 1.
iPad 1, okay. What you're probably seeing is the difference between the programmable pipeline and the fixed function texture samplers pipeline that you can configure through ShaderLab. When we were doing Creevers on the iPad 1, there was a significant amount of overhead to using programmable shaders at all. Where if you used the older, the fixed function ShaderLab stuff, it was just faster. So presumably what you're seeing is some kind of fallback happening where it's not using the programmable ones until you allow it to use ES2.
I think once you switch to the GL ES2, all it virtualizes them all into programmable shaders. And it doesn't, I think it
yes, also, he's absolutely correct. ES2 does not support fixed function pipeline at all. It internally converts your fixed function shaders into CG shaders, or GLSL shaders in that case. And on the iPad 1, this is just going to be slower.
So is there any way around it?
Don't use ES2. Unfortunately, it's the only way. It sucks. Or use a newer iPad.
You also mentioned that iOS has a problem with indirections. So if I wanted to apply
yes, okay. I will rant a bit about iOS's bizarre rendering. Well, it's not iOS's fault. This is the fault of PowerVR, the chipset maker of their graphics chip. They use a thing called tile-based deferred rendering, where it, summarize real quick, it splits the screen up into patches, arbitrarily 32 by 32 pixels or something like that, and it renders that whole patch at once. Because of the order in which it does things, if it ever finds out that the data in the patch already is invalid, it has to kind of restart, and it slows things down. When you do a texture indirection, it looks up the text. It tries to look up all the textures before it gets to the final step. So when you're not doing texture indirection, everything's there and waiting when it gets to rendering the tile in GPU memory. If you do a texture indirection, it can't do that. It gets there, the first stage of your texture lookups are there ready and waiting, and then it has to do another stage, which bounces it back to an earlier step in the pipeline, and has to go through the rest of it again.
So would there be a more efficient way, not for instance, depth of field, but just an overall blur of your entire image? Is there a more efficient way to handle that if you can't really use
You should still be able to do yes, you can still do a simple blur in that case. The trick is to do all of your UV coordinate manipulation in the vertex shader. If you do it in the vertex shader, it's safe. It's all in place before it does the texture lookups. And then in your pixel shader, you just do texture lookups aligned with whatever you passed in.
Thank you.
This was for this side.
Not really a shader question, but what is the best way to detect whether or not you're dealing with a retina screen? And can you differentiate, like, you can just query the screen size, right, and like know that it's the iPad 3 because it's the big screen. But then if you want to do something different based on like knowing how much processing power you have, how can you differentiate between like the iPad 1 and the iPad 2?
In Unity, there's a class called System Info that exposes a whole bunch of like version strings of various things.
Yeah.
You might be able to tell from there. I don't know a specific answer to your question because I haven't done anything with Retina iPads, unfortunately. Sounds like you could do it based on what I know from resolution, but I'm not 100% certain.
Yeah, you can just pull that out. Like there's a function. They'll tell you which.
Alex, has Conrad?
It's not that file info one?
All right, here.
No, he's not here. But I mean, has he done it? Done that before?
It's in the document.
Has he done that before? I mean, if he does, we can like connect him with Conrad.
Oh, yeah. We should
But I'm not sure though.
post on like a Facebook group about this, I guess. One of our other developers, Conrad, does know the iPad stuff a lot better than I do. He may be able to answer you more directly.
Going back to a few posts ago, you said that you had code that would determine what kind of shader or model to use based on like what the hardware restrictions. Was this something that Unity provides?
This is something Unity provides. Unity, this whole fallback system, Unity just does this. Abuse the hell out of it. It's fantastic.
Is that does that have like a compile time you compile to the device? It actually happens during runtime?
It happens at runtime.
Okay.
Under the hood, it compiles all those versions and it will ship all of them with your game. And then at runtime, it will determine which ones it can actually use. This means you can, for example, there's a property somewhere called the Global Maximum Shader LED. You can just fiddle that at runtime through like a slider in the graphics options page or something if people want to tune it for their particular machine.
Do you guys incur like much of a speed loss from it?
Nope.
Okay, and for example, with your blob texture, now what I'm speaking as someone who's not an artist at all, what would be a practical effect of that in a practical use of that application in the game development environment?
That one, if you want to make a game that looks like a painting, basically,
Okay.
that was what that came from.
Okay.
And honestly, if I were to sit down and try to do that now, I would want to tune that a little more and add some stuff to it. That was like an old, kind of terrible attempt at that. It's a good example of terrible textual cuts.
Okay,
It's entirely a stylistic choice.
gotcha. So it's not like it's not like a fade effect where you go like or a scene transition.
You could use it for that. Once it's there, you can, put a float in there that modulates how strong it is at any given time. Do the, Super Mario Brothers, the SNES one.
Super Mario World.
Where it does the it goes pixely as you fade.
Right.
Do something like that. Totally. In Guns of Icarus, when you die, we burn in the edges of the screen like it's a piece of film and fade to black.
That's all your shader effects.
Yes, that's the shader effects. That's actually not even post-process effects, because that's just drawing the transparent quad on top of, right in front of the camera. But you could do it in post-process effect as well. There's another graphics programmer and I like showing my work, it's pretty up. And keep asking me questions while I do this.